Okay, good day guys. This is Ash here, or Ash Power, just showing my final progress with regards to the code for part A of my digital data systems project. So part A is an EKG sample. I had two cracks at this and both ended up a little bit different. I abandoned one halfway through and went to a different methodology, but I'm going to show both just to show that I have been indeed working on it. So the first part is something that works on all of the samples. So I've got my code here. This is the initial code that I used in order to try and work all the sample data sets in one program so that I could see how I was tracking as the project went along, but managing it seemed harder and more time consuming than I initially anticipated, and I ended up leaving it. So I'm just going to run that, pressing F5, and you'll see that down the bottom here we have which sample would you like to analyze coming up. And what that's asking for is, out of all of the samples, which one am I interested in? So if I was to say, for instance, sample 4 and press enter, then I get my loading data message, which I have a pause on, and then eventually I get my results, which I'll just dock for everybody's benefit. So it pulls just the actual sample, it gives you a sampling rate at the top there, which is calculated, and then down the bottom it gives you your BPM, which for this sample would be 60. Yeah, it doesn't do the peak analysis or the filtering because I stopped on this project a little bit earlier. So that was one attempt that I tried, and then I'm going to show the other attempt now. So this is my other project. This one requires you to have a specific sample loaded at the start of the project, numbers 1 to 8 or whatever sample you want, and that's just specified at the top here. So you can change that number to say, I know for a fact that number 8 is a very bad sample to work with, so if I was to go, for instance, number 6, which I believe is a good one, and then I was again to run my code, and this one takes a little bit longer, but eventually we will get an output, which has just come up on my screen there, which I don't believe will come up very well, so we'll go maximize. So you can see there that I've got my sample, my peak detection, an isolated wave, which has then been smoothed. I then identify the location of my P wave in particular and my T wave, but I can also see that the troughs need to be measured. So in order to achieve that, I invert them. So for this, the rest of the results will be in my command window. So I will get the duration of my T wave in seconds, the duration of my P wave in seconds, based on the average time beats per minute, which is just a different way of calculating it, but the actual beats per minute that I'd like to use would be 54 beats per minute, and that can be repeated for any sample. So if we'll go to sample 2, for instance, and then running that program again, we have 60 beats per minute this time around, and a very similar T-wave time, but P-wave is different. So again, we have that result. Actually, looking at it, I'd say that sample 6 was also bad in terms of my program being able to extract the troughs on the P-wave and T-wave, whereas this is an ideal situation where the peak of my P-wave and the peak of my T-wave has been found, and then when I invert it, the troughs have also been found, which allows me to measure from point to point. So I'd actually say the previous sample wasn't working, so that was my bad. But yeah, that's my working code. A lot of improvements I'd like to make, but time is a constraint.